Welcome back, Algebros. Last time, we discussed determining if relations are functions when we were given a list of points. And we discovered that if any x has more than one possible output, it's a broken relationship, and therefore not a function. So, what happens when you're not given a list of points? What if you're given a continuous graph? We do know that these kinds of graphs are indeed just a culmination of a bunch of infinitely many points that just create these kinds of curves, whether they're diagonals or zigzags or curves or whatever. But good luck trying to write down every single possible point from now until infinity. I'll call you when you're done. So which one of these are functions? How can we tell? Do we have a way to know very easily? You bet your butt that you do. Let's have a look. All you really have to do is take your hand, hold it vertically over the graph, and sweep from left to right. It is a very visual and a very physical kind of test as well. You want to see, does your hand ever touch the curve twice or more? If the answer is yes, it's not a function, and if the answer is no, it is. Much like we saw before with input and output maps, it is the opposite kind of thing. We're testing for a negative. So if we do touch more than once, then it's not a function. If we do not touch more than once, we touch only once, it is. Let's have a look at a couple of graphs and see this in action. Obviously, you can't see my hand hovering over this. You'll definitely see it in class when we go over this together. So instead, I'm going to draw a couple of vertical lines to indicate what the message of this is. You are sweeping over, and you are trying to see, is there any point that these curves will end up touching the vertical line twice or more? Again, assuming since these graphs go on forever, assume the trend continues as normal. So this one right here, a diagonal straight line. Every single time that I try to draw a vertical dotted line, we only ever touch once. Since we only ever touch once and not twice or more, that means that the vertical line test passes. In that case, this is indeed a function. How does this relate to the grand machine or to the video game controller example? Well, remember that each individual point is basically an xy. And that's basically telling me, oh, for this x, there is an output as the y. For every x, there is some kind of output as the y. So if there's ever a point where an x has two possible y coordinates, that's a situation of jumping, hitting the ceiling, crashing into the ground, accidentally punching yourself in the face, and all that jazz. Have a look at the next one right here. I'm only going to take one vertical line right here. And notice from that vertical line alone that I have 2 points that it's cutting. Imagine if this one right here is inputting an A, and this one right here is the jump, with a punch as the y coordinates. Once again, that goes back to the example of a broken controller. We can't have that without getting super angry. Please don't get super angry. So in this case, we have that no, it's not a function. Once again, take that hand, sweep it over, you will have infinitely many points in this case, where we touch twice or more. Looking at the next one down here, the one with the zigzag, kind of looks like an E if you ask me. Take whatever vertical dotted lines you want, you're going to notice, oh gosh, we're touching more than once. There's 4 possible ways that this could go wrong. How the heck am I going to know how to play this game? Nope, I'm not dealing with that. That is absolutely not a function. So I'm not touching that. Just kidding, I kind of did, just to say no. In this case right here, though it's not drawn perfectly, you can assume that this up and down oscillating format just continues as it is. If you see this on an exact graph, you will see that no matter how hard you try, there's only ever going to be one output for every input. Again, assuming the x-axis is the inputs, the y is the outputs. Every input only has one possible output, so this indeed is also a function. Just take that vertical line with your hand, sweep over, and you're good to go. This being said, you don't have to draw the dotted lines yourself, those vertical dotted lines I've been doing. I've only been doing that here because it's impossible for me to show my hand while also doing this on an iPad. There's only so much a mere mortal man can do. I've got a bunch of samples right here. I'm going to do the first two myself, and I'll leave the rest for you as you tries. Let's look at the V shape right here. It bends almost like a check mark or a V, but try as you might, look at this. There's never a point where there's two outputs for an input. Not even here at the bend of the V. It's still one possible input, say it's 1, and then one possible output, say that's like -5 or something, I don't know. These graphs don't have to be exact. But at the end of the day, there's only one possible input for outputs. Every single time I draw a vertical line, there's only one time I cross the curve. So this is a function. This next one's a bit tricky, so I decided to do it together. Obviously, I am no expert, but if you try to plug this into the graphing calculator, like GeoGebra or Desmos, try typing in y equals tangent x, or tan x, and you'll see this in action. Once again, you'll have every possible time that you try to take a vertical line, you'll only ever touch once. Even if these red portions seem to go on forever and seem like they're vertical, they actually aren't, and we'll see this more in class. So indeed, in this case, is it a function? Yes! There's 5 more examples right here, and I'd like you to try them out for yourselves. Draw a mini sketch of them as best as you can, on a piece of paper or a whiteboard or in your notebook. Give them a try. I'd love to see what you come up with in class very soon.